Let us see how to solve this differential equation. So here, finding complementary function is not a big task. So we need to find particular integral. So you know the particular integral can be formed like this: y equal to 1 by d square minus 9d plus 18 acting on e power minus 3x. This is what you have. Now you know this can be expressed in terms of partial fractions. So this can be expressed as d minus, you want 18 and you have 9 here, so 6 3 can give you 18. So d minus 3 into d minus 6 acting on me. Now I'll express this into partial fractions, that is 1 by d minus 6 here minus 1 by d minus 3 here. So in the numerator I'll have minus 3 plus 6. So I need to divide this with 1 by 3. So now it is enough to know what is the action of this guy on e power minus 3x. And before seeing that, let me recall the formula, that is 1 by d minus alpha acting on f of x. Okay, so we'd like to find its value. What is this thing? That's what we'd like to find. So let's assume that this expression is equal to y. I'm going to derive the formula for this now. So let's assume this is equal to y. So if you assume that, so this is same as writing f of x equal to dy minus alpha y. Okay, now this is a first order differential equation, that is dy by dx minus alpha y equal to f of x. So it is looking like a first order linear differential equation, right, with constant coefficients. Now you can actually recognize what is p of x here. See, it is of this form, dy by dx plus p of x into y equal to q of x. So here p of x is equal to minus alpha, whereas q of x equal to f of x. Now we know how to find integrating factor for this guy. So integrating factor here is e power integral p dx, that is e power minus alpha into dx, which is nothing but e power minus alpha x. Now you know the general solution, that is integrating factor into y, that equal to integral of q into integrating factor into dx. Anyway, we'll write plus c, but here I'm not going to write plus c. Why? Because this one we are seeing it as a part of a particular integral. Like this is what we'd like to find, right? Now y into e power minus alpha x, that equal to integral, you know what is q. Q is nothing but f of x, and integrating factor is e power minus alpha x into dx, right? So our aim is to find what is y. So therefore y equal to, you just send e power minus alpha x to the other side. So the formula for this is e power alpha x integral e power minus alpha x into f of x into dx. Therefore you can see the formula for 1 by d minus alpha acting on f of x, because we assumed y is nothing but this expression, 1 by d minus alpha into f of x. So now, so the formula is e power alpha x integral e power minus alpha x, right, into f of x into dx. Now this is the formula, we derived formula here. Okay, now we are going to use this formula to solve the given problem. So here I need to add this operator 1 by d square minus 9d plus 18 on this function. So I'd like to see this individually. So first of all, I'll see what is 1 by d minus 3 acting on e power of e power minus what is given minus 3x. Okay, so this is nothing but, as for the formula, this is e power alpha x. You see where alpha is 3. In place of d minus alpha, I have d minus 3 there. So e power alpha x, that is e power 3x, integral f of x. F of x is e power minus 3x into e power minus 3x, that is e power minus alpha x into dx. Right? Now this equal to, now you can take e power minus 3x equal to u. So the moment you take this is equal to u, so let me solve the subpart here. If you take u equal to e power minus 3 alpha 3x, this implies what happens to du? Du is nothing but minus 3 e power minus 3x into dx. And what happens to this entire integral? So I'll have e power, in place of this I need to substitute u, that is e power u into, now this is minus 1 by 3 into du. Why? Because e power minus 3x into dx will become minus 1 by 3 into du. You know its integration. So this is e power u minus 1 by 3 again. Okay. So now from this I can directly write the integral for this guy is nothing but e power 3x into, this is e power u, that is minus of e power minus 3x, okay, by 3. So therefore we can say 1 by d minus 3 acting on e power minus 3x, that equal to e power 3x into minus, you can keep it here, e power minus 3x by 3. Okay, so we are done with 1 by d minus 3 acting on this guy. And next, what is left? You need to find what is 1 by d minus 6 acting on this guy. So let us try to see. So other expression is 1 by d minus 6 acting on e power minus 3x. Now this is e power 6x, if alpha is 6. Integral, you have e power minus 3x into e power minus 6x. I'm gonna write it like this. There I need to write actually e power minus 6x. I'll write it like e power minus 3x times 2. We are allowed to write it like this, right? Now this is nothing but e power minus 3x. Okay, you can write it as whole square of it. So now using this technique, this is how I'll write e power minus 3x into e power minus 3x into dx. You're supposed to have e power minus 6x. That only I have written it as 2 parts. Why? Because the moment I assume u equal to e power minus 3x, this will become u, right? And whereas this one will become du. Okay. Again, we'll have the same assumption. That is u equal to e power minus 3x. You know what is du? Du is nothing but minus 3 into e power minus 3x into dx. This is what du. Now substitute everything here. So the moment you substitute 1 by d minus 6 acting on e power minus 3x, right, that equal to e power 6x. I'll write it as it is, but here I'll use u substitution inside. So that is e power u, that is u into minus 1 by 3 into du.